Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to subject CHM421, which is analytical chemistry. This video will be continue the topic 1, units for quantities and concentration, on the subtopic of molarity, normality, and stoichiometry. This is more to the unit for concentration. On the previous slide, I have explained about the concentration of the solution. Concentration is the amount of solute in a given volume of solution. We can have, when we dissolve a particular amount of solute in a specific volume of solvent, it can give us a specific concentration of the solution. Is to refresh back, solute is the substance present in smaller proportion of the solution. It can be solid, liquid, or gas. Solvent is the substance that normally used to dissolve the solute. It can be liquid and present in the larger proportion of the solution. Solution is the result when we dissolve the solute in the solvent. It is the homogeneous mixture of two or more substances consists of solvent and solute. Water is the universal solvent for the most of the solution. So this is the formula to calculate the concentration. Concentration is the mass of solute in a gram over volume of solvent in liter. So here, what is the concentration of water? Uh, we know the molecular mass of water is 18 gram per mole. That can be calculated using the periodic table. The density of water is 1 gram per milliliter or 1000 gram per liter. Therefore, the concentration of water, because we know the concentration is mass over volume, so we can calculate from the this molecular weight of water and also the density of water. So from the density, we know from the density, we know 1 liter of water, it contains of 1000 grams of water. Okay, so from the molecular mass, we know from the molecular mass, we know 1 mole water contain of 18 gram. So when we want to calculate the concentration of water, it can be represented in different units. It can be presented in the molarity, or it can be presented in normality, or it can be presented in the percentage. concentration. We will cover how to convert the concentration in different unit on the another slide. In here, the concentration of the water will be presented in the molarity form. So, molarity, of course, I not teach you yet. So, molarity is the mole per liter. So, the from the molecular mass of water and also the density of water, we can calculate the molarity of water. This mole per liter, meaning that the density 1000 sorry, the density 1000 gram per liter over 18 gram per mole. So you can cancel this gram and then you can obtain 1000 over 18, 55.6, 55.6 mole per liter. So mole per liter is 55.6 molar per. Okay, don't worry about this one. If you still confused, on the next slide we will explain in detail about the molarity. Okay, as I mentioned just now, the concentration of the solution can be expressed in many ways. It can be expressed in molarity, normality, molality, percentage concentration, ppm, and also ppb. So in this video, we will focus on to molarity, normality, and also molality. The percentage concentration, ppm, ppb, will be covered in another next video. Okay, as I mentioned just now, in order to calculate the concentration of any solution, it should be mass over volume. Concentration should be mass over volume. So the mass in this formula should be a unit of gram, and the volume should be in a unit of liter. Therefore, the unit of concentration is gram per liter. Mass concentration. This one is more to mass. This formula is mass concentration because we're using mass. So this is the example. 500 ml of solution containing of 26.3 gram FeCl3. Calculate the concentration of Fe3 plus in gram per liter. When it mention about gram per liter, this one, gram per liter, it should be mass concentration. Mass over volume. Okay, So it's asking you about the concentration of Fe. So in this 500 ml of solution contain of 26.3 gram FeCl2, it's asking you about what is the concentration of Fe3 plus in this solution. So uh, from the formula of mass concentration, we need the mass of Fe. We need the mass of Fe and also the volume of the solution. The volume of the solution is okay because it's already uh, given, but we have to calculate the mass of the Fe. Because this solution, if you can draw the diagram, this is a beaker. So it's about 500 uh, ml of solution. Within this solution is containing of 26.3 gram FeCl3. So question is asking you uh, about the concentration of Fe3 plus. Okay. So, of course, you need to calculate what is the mass of Fe3 plus in this solution. So, you have to calculate the mass of Fe3 plus first. So, in order to calculate the mass, the way is similar with the previous slide. Sorry, on the previous video on mole and millimole. So we have to calculate the mole of FeCl3. It's a mass 23 gram over molar mass of FeCl3. Uh, fif- sorry, 55.8 plus 3 times 35.5. Okay, this one is the atomic mass of Fe, and this one is the atomic mass of Cl3 that can be obtained from periodic table. So you have to calculate the mole number of FeCl3 plus, because later you have to calculate the mole of Fe3 plus in FeCl3. So 35 35.5 times 3 plus 55.8 equivalent, and then mass 26.3 divided by answers. So 0 point, sorry, maybe you confused. Maybe you confused. I use another way. 26 uh, you can calculate this one using your calculator. It's up to you how you click your calculator. I have my way. Times 3 plus 55 times 3 plus 55.8 uh, 26.3 divided by answers. So 16 sorry, it's 0.1620 20 mole. So the mole Fe 3 plus should be 1 the power 1 times 0.624. Well, this one we already covered on the previous video. You can refer back how to calculate the mole of something in the compound. So this one is 1620 mole. Therefore, it's not before. So we can calculate the mass of Fe 3 plus. Mass is mole times molar mass of Fe 55.8. So 55.8 times 0.6020 9.0396 gram. Okay, so after you obtain a gram, and then you can calculate the concentration of Fe. It's a mass 9.0396 gram over liter. So now this liter in the 500 ml. So you have to convert into liter. The 500 ml. Sorry. You have to convert it to liter. 500 ml times milli 1 to the power of minus 3. So equivalent to 500 times 1 to the power minus 3 equivalent to 0.5 liter. So this one 0.5. So 9.0396 divided 0.5 equivalent to 18.1 mass in gram unit of volume in liter. Okay, so similar with this example, you have to try by your own, even though the answers is already given, but you have to work it out. Okay, all right. Molarity. This is one way to present the unit of concentration of solution in terms of molarity, symbol of capital M. The molarity is the number of mole of solute per volume of solution, the symbol of M. So this is the formula that you can calculate the molarity. Moles of solute over volume of solution. So you can write here, molarity is mole per liter. Of course, you can calculate the molarity in unit of millimole per milliliter. So from the molarity itself, you can calculate the mole or the millimole. But the most important point is you remember this formula. Molarity is mole per liter. Okay. This is the molarity. Mole per liter is the mole divided liter. Okay, so the unit of molarity is mole per liter, the mole in unit of mole, the volume of solution in the unit of liter. As I mentioned just now, from the molarity formula, you can calculate the number of mole. Number of mole is molarity times volume, because you know uh, mole is molarity is mole per liter, so mole it should be molarity times liter, like this. Okay, molarity versus times volume. All right. So now we try how to calculate the molarity of this gram of sulfuric acid in 500 milliliter of solution. So you can try this one. Molarity we know uh, mole per liter. So this mole, this is given in gram. So you have to calculate the mole. Mole is mass over molar mass. Okay, and this 500 milliliter have to convert into uh, liter. 1 liter equivalent to 1000 ml, and then you can obtain 0.5 liter. Or another way, you can calculate 500 ml times milli, 1 power minus 3, and then same answer 0.5 liter. So as I mentioned just now, if you want to calculate the molarity, is a mole per liter. So you have to calculate what is the mole of sulfuric acid. So in order to calculate the mole, is a mass over molar mass. So sulfuric acid, the chemical formula H2SO4. So the mass 10.5 divided 98. 98 you can obtain from periodic table to calculate the molar mass of sulfuric acid, and then you can get 0.1071. 10.5 divided 98, 0.701071. 1071. Okay. So after you obtain a mole, uh, and then you can calculate the molarity. So molarity is mole per liter. So the number of mole just now is this one. The liter that we already converted from milliliter to liter is 0.5. So 0.171 divided 0.5, you can obtain 0.1252 1242 molarity. Okay, or this one 0.2142 mole per liter, or 0.1242 mole per liter minus, and so on. All right. Okay, this is another example. Find the molarity of solution of 0.6 grams sodium chloride in 100 ml of solution. So the molecular mass of sodium chloride is given again. If you obtain get in equation, you have to take note. Find the molarity. Molarity is mole per liter. So you have to convert this gram of sodium chloride into mole. And then this 100 ml you have to convert into liter. So you can calculate what is the molarity. So the number of moles of sodium chloride of 0.6 gram 0.6 gram divided by molecular mass. So molecular mass is already given, and then you can calculate 0.6 divided 58.5, and then you obtain 0.0103 gram per mole. So molarity is a mole per liter. So you already obtain a mole, and then you convert this volume milliliter kepada liter. Okay, so 100 ml times 1 liter equivalent to 1000 ml, and then you can obtain 100 over 1000, 0.1 liter. So this mole divided by 0.1 liter, you can obtain 0.103 molarity. So it can be written as 0.103 mole per liter, or it can be written 103 mole liter minus 1. Okay. Okay, another exercise related to the molarity. I think it's quite similar. Uh, a 500 ml of solution contain 26.3 gram FeCl3. Calculate the molarity of Cl3. So it's only asking about Cl3. Again, uh, molarity is mole per liter. So you have to calculate the mole of Cl minus. So in this, so you have to calculate uh, the mole of this FeCl3. So first you have to calculate mole FeCl3. After you obtain the mole of FeCl3 is mass over molecular mass, 55.8 plus 3 times 35.5. So you can obtain 35.5 times 3 plus 55.8, uh, 35.5 times 3 plus 35.8, and then 26.3 divided by answer, you can obtain 0.162 or more. Okay, and then second, you can calculate mole of Fe. Sorry, mole of not Fe, mole of Cl minus. Because of Cl only one, so 1 times 0.1620, so 0.1620 more. So yeah, it's you already obtain mole, which is this one, and then the volume is 500 ml. You can convert this one to 500 ml of 1 liter, 2000 milliliter. So 500 divided by 1000, 0.5 liter. Okay, so now molarity Cl minus, it should be mole. 16 to 4 mole per volume of solution, 0.5 liter. So 0.1620 divided 0.5, you can obtain 0.324 liter. Oh, sorry, some mistake here because this is Cl. Cl in this formula, 3Cl. So you have to change this one. It should be 3 because of 3 Cl atom in the FeCl minus. So 3 times 0.6616, 3, 3 times 0.1620, 0.4860 more, 486. Okay, so this one we have to change 0.486 and then divided 0.5, 0.972, not more, uh, mole per liter or 0. Mole, molar, molarity. Okay, all right. Okay, we done with the molarity. We done a few exercise. You have to try by your own. Now we moving forward to the molality. Molality is small m. The molality is the number of moles of solute dissolved in 1 kilogram of solvent, small m. If molarity is a mole of solute per volume of solution in liter, but molality per mass of solvent, so 1 kilo of solvent. Normally, the unit of molality we use to express the concentration of colligative properties. No worry about this one because this is another subject. In the colligative properties, it's about the boiling point division, freezing point depression, and also the osmotic pressure. So this is the formula to calculate the molality, mole per kilo mass of the solution. So if you still remember, this is not molarity. This one is molar molality. Okay. So if molarity is a mole per liter, then molality is a mole per kg. So at least you have to remember these two formula of molarity, and this is a formula of molarity. Okay, so this example is about molarity. If you have 10 grams of Br2 dissolved in 1 liter, give you a volume of 1 liter of cyclohexane. What is the molality? You know, molality is mole per kg. The density of cyclohexane is 0.779 kilogram per liter. So, first you have to calculate the mole of Br2. You are given here a gram. So, this gram you have to convert into mole. And then after you get the mole of Br2, and then because molarity is per kilogram, now the cyclohexane given in the unit of volume, 1 liter. So you have to calculate in 1 liter how many kilo of cyclohexane. This is why you have to use the density. So the mole of Br2 is mole is mass 10 over Br2. Before the product table, you can get 159.8. So 10 over 1.9.8. So obtain 0.0626 mole. Okay, so that's the number of mole. And then from the density of cyclohexane, 0.779 kilogram per liter, meaning that 1 liter is equivalent to 0.779 kilogram. However, okay, so it dissolved in 1 liter. So the mass is 0.779 kilogram of cyclohexane. So therefore, you can calculate the molarity is a mole 0.0626 mole over kilogram of solvent, 0.779 kilogram. So you can obtain 0.0626 divided 0.779. So you can obtain 0.08. 0.08 more. Oh, sorry. 0.08.4 mole per kg, equivalent to 0.004 molarity. So this one seems with the final answers. All right. Okay. So so far we done molarity and molality. Molarity is mole per liter. Molality is mole per kilogram. So now we move forward to normality. This normality is a bit complex. Is compared to the molarity and molality, but it can be done. Okay, we do it slowly. So normality, capital N. Normality is the number of equivalent reacting unit, per volume of solution. So the symbol is N. This is unit of concentration exclusively to measure the concentration of acid or base in during the titration. In acidity, in alkalinity analysis, pH adjustment of BOD, ammonia, and phosphorus sample. Similar in a concept to molarity, mole per liter, but it's emphasized on the molar concentration only for the acid component, which is H plus in the acid solution, or it only focus on the base component, which is OH minus hydroxide in the base solution. That is about the normality. If you know the molarity, molarity is mole per liter. If you know the molarity of the acid or the base solution, it is quite easy to convert the molarity into normality. Okay, we can convert molarity into normality by multiplying the molarity with the number of hydrogen or the number of hydroxide ion in the acid or in the base. So this is the chemical formula to obtain the normality of that particular acid or base solution when you have information of the molarity. So molarity times number of hydrogen and also or the number of hydroxide ion. Okay, so for example, if we have 2 molarity of sulfuric acid, so we can have normality of 4, 4n. Why? Uh, because from the formula we say normality, it should be molarity times number of hydrogen. Number of hydrogen or number of hydroxide. So number of hydrogen in this case is 2. So it's a 4n. So for this 2 molarity of sulfuric acid, normality can be 2 times 3. 3 is number of hydrogen atoms, so it's a 6 normality. Okay, all right. Okay, uh, this one is if you are given the molarity of that particular acid or base. It's a very straightforward calculation. But if you don't have molarity information in the equation, and you are asking to do the normality, so this is the formula that you will use to calculate the normality. From the definition, we said normality is the number of equivalent of reacting unit, AQ, over the volume of solution. So you can write here molarity is mole per liter. Molarity is mole per kg. And normality is number of equivalent reacting unit per liter. Okay. All right. Uh, This one we come back later. We see how. Okay. We see what we have here. Example. A solution. One of the solution prepared by dissolving 3.57 to 5 gram of H3PO4 in 500 ml volumetric flask and diluting it to the calibration mark, meaning that the volume of the solution is 500 ml, containing of 3.57 to 5 gram of that acid. Calculate the normality of the acid solution. So as we know, normality is the because molarity is not given, so is equivalent per liter. Or we can try another way, maybe, because we know normality also can be calculated using molarity times the number of acid or the number of hydroxide. Let's see, we try this formula. So if we want to try this formula, meaning that we have to calculate the molarity first, mole per liter. So we have to get the mole of this acid. So mole is 0, mole is 3.5725 divided by uh, molecular mass of H3PO4. So uh, 1 times 3 plus phosphorus, you check your periodic table, 30.98 plus oxygen, so 16 times 4. Okay, so you can calculate the mole of H3PO4. We try first this formula, is it work or not? 16 times 4 plus 30.98 plus 1 times 3 is 3, and then 3.57 through 5 divided by answer, you can get the mole number. So 0.0365. So the mole number is, I write it here, 0.0365 mole. In volume, 500 ml, so it's equivalent to 0.5 liter. So 0.0365 mole divided 500 ml, 1 liter, 100, okay, over 1000, 0.5 liter. So 0.065, 0.36, 0.0365 divided 0.5. So it's 0.073 molarity. So then normality is 0.03 times number of hydrogen in this formula is 3, so times 3. See how is it get same answers? 3 times 3. Yeah, we can get same answers. Okay. So meaning that even though the molarity is not given, we still can use this simple formula. Normality is molarity times the number of hydrogen and hydroxide, but you have to calculate the molarity first. This answer given in this slide is using the this formula, equivalent, the number of equivalent of reacting unit per volume of solution in liter. So, okay, let's work it out, how this can be done using the number of reacting unit per liter. Okay. All right. Uh, the number, the normality equivalent per liter is I said just now, you can calculate the normality using this formula, equivalent per liter, or you can using the molarity of times the number of acid in hydroxide. So this one is more easier, but you have to calculate the molarity. So for this one, you have to understand what is the number of equivalent of reacting unit. So we have to calculate the number of equivalent of reacting unit. It's the same question. Yeah, it's the same question. Uh, it is it's the same question. I use this slide to explain. So first we have to calculate we want to calculate this one using the formula of N equivalent per liter. Okay, so we have to calculate the mole of the acid. So the mass over the molar mass. Molar mass is we calculate here. Where? Molar mass of the H3PO4 is 98, and then you can get the mole number. So now this is important information. You can calculate. You have to calculate the number of equivalent in H3PO4. So in this three H3PO4, 1 mole is equivalent to 3 EQ. Why is 3 EQ? Because hydrogen, it has 3 hydrogen atom. So for this substance, from 0.0365 mole, you can obtain how many reacting unit, equivalent reacting unit. From this one, you know 1 mole is equivalent to 3 AQ. So 0.0365 mole of H3PO4 is equivalent to 0.1095 AQ. And then after you obtain the AQ, and then you divide it over you divide it over volume of solution. The volume of the solution in this case is 500 ml. So convert into liter, 500 ml times 1 liter equivalent to 1000 ml. You can obtain 0.5 liter. Okay, so the equivalent divided by liter, so you can get this answer, and you can get 0.21 normality. So as I said just now, you can calculate the normality either using molarity times the number of uh, hydrogen or hydroxide, or you can calculate the normality using the equivalent per liter. So equivalent per liter, you have to understand this one. Okay, this one, equivalent per liter. So you have to calculate the overall mole, and then you can calculate what is the equivalent reacting unit. So my advice, maybe you can just focus this equation. It's very simple, but you have to calculate the molarity first. Okay. Calculate the N of the solution prepared by dissolving 2.3543 gram of sulfuric acid in 1000 ml distilled water. So I will use the formula of normality, molarity times hydrogens, or H minus. So I have to calculate the molarity is a mole per liter. So mole per liter, the mole, it should be mass 2.3543 divided 98.03. This is a mole, and then over volume. So volume in this case is 1000 ml. So it's equivalent to 1 liter. So uh, 2.3543 divided 98.08, and then divided 1. 0.24, 0.024 molarity. Only this therefore normality is 0.024 times how many hydrogen in this sulfuric acid times 2. So it's a 0.048 normality. Okay, so this is the normality. But also you can calculate using the normality equivalent per liter. So you have to familiar with this one to calculate the equivalent of reacting unit. So it's up to you which formula you want to use. Either you want to use this normality, molarity times number of hydrogen hydroxide, or you can use this normality equivalent per liter. Okay, calculating normality is another explanation. Determine the compound equivalent weight. This is done by taking the compound molecular mass, dividing by the number of hydrogen ions in hydroxide. So if we have sulfuric acid, the molecular mass is 98 from the periodic table. The number of acid hydrogen in this sulfuric acid is H plus is 2, and then the equivalent weight is 98 divided by 2 is 49. How you can get this one? Like this one. Okay, so uh, number of equivalent. Okay, 1 mole is 2. So uh, how many moles? Equivalent weight, because you want to obtain the mole number. 1 gram per mole, meaning that uh, 90. How to say this one? I'm worried to you quite confused. This one using this chemical formula. Okay, this one is using the chemical using this formula. Number of equivalent is the mass over equivalent weight. The weight is mole per molar mass. Okay, so equivalent weight is millimole per number of reacting unit. So this one is the equivalent weight. This why you in this case equivalent weight is the molar mass divided by number of uh, number of what? Forget already. It's number of reacting unit. So reacting unit is 2. So 98 divided by 2, you can obtain the equivalent weight or equivalent mass 49. Same goes to H3PO4 from the predictable molecular mass 98. The number of reacting unit is 3 because it's 3 here. So equivalent weight is molar mass over reacting unit 98 divided by 3, that is 2.6. Okay, sodium hydroxide, the molecular mass from the product table 40. The reacting unit for this base is only 1, OH 1. So equivalent with 40 over 1. Okay. And also we can calculate the amount of grams needed per volume of water for normality. So the gram needed is the undesired times equivalent weight. So this why we have to know the equivalent weight, molar mass times number of reacting unit, volume in liter. Okay, so how many gram? So this is the example. How many gram of sodium hydroxide would you need to dilute to a liter to make one normality of sodium hydroxide? So we know from the formula we said gram, sorry, we know gram needed is undesired. So undesired is 1 times equivalent weight is molar mass of sodium hydroxide 40 equivalent weight 40 divided by 1, and then volume of liter, volume in liter is 1 liter. Okay, so you can get 40 gram. You can calculate this one using this formula. N desired times equivalent weight and also times volume in liter. So this is another example how to make 0.25 liter in 0.05 normality potassium hydrogen pentylate solution. This is an acid solution. So from the mass needed, normality is 0.05 times equivalent weight. Equivalent weight is gram. Equivalent weight is a molar mass. So molar mass of this compound from the product table, and then the number of acid hydrogen in this compound is 1, and then times liter 0.25. So you can obtain this one 0.05 times 204 4 times 0.25 2.55 2.55 gram. Okay, so this one similar to this final answer. The okay, yeah, that's it. The rest you can read. Okay, now we go to the friction. So far we done molarity, normality, and also molarity, molality, and normality. Now we reached to the fraction. Fraction is A. Fraction is more to compositional calculation. For example, fraction of A is the percentage of A over 100. If we have two components of A and B, meaning that fraction A and plus fraction B, it should be equivalent to 1. So this is the example related to the fraction or compositional calculation. So in this manganese steel is a very strong and normally used for the railroad nails. So this manganese, the composition is iron, manganese, and also carbon with different mass percentage. The total of this one is 100%. So what is the mass of each of the three elements in 25 gram of sample of manganese steel? Okay, so it's asking you about in this 254 gram of manganese steel. It contains of what is the mass of uh, iron, what is the mass of manganese, and what is the mass of carbon. Okay, so you have to calculate. So it's from the question we know 100% of manganese steel it composed of this mass percentage. So in 254 gram of manganese steel, it composed of how many gram of Fe, how many gram of mangan, and also how many gram of carbon. So we can calculate the mass percentage of Fe, for example. We know we can do it in this way. We know for Fe, 100% of manganese steel is contained of 86 gram, 86% of iron. So 100% of manganese steel is equivalent to 254 gram. So you can calculate X. So X is 254 times 86 divided by 100. 25 256 254 times 86 divided by 100. 218.44 gram of Fe. Okay, so you can calculate for what manganese for manganese Mn. We know 100% of steel is equivalent to 13% of manganese. So in 100% of manganese is 254 gram. So you want to find X. So X is 254 times 13 over 100. 254 times 13 over 100. So 33.02 gram of manganese. Okay. So answer is here 33 gram. So for carbon, we know in 100% of manganese steel, it contains about 1% of carbon. So for 254 gram of manganese steel, it contains of how many carbon? Okay, so uh, X should be 254 times 1 and then divided by 100. So it should be 254 times 1 divided by 100, 2.54 gram of carbon. Okay, so yeah, 3 gram is round up. So it can be 2.54 gram. All right. So this is another question related to the fraction. A sample of brass is composed of copper and also the remainder is zinc. What is the mass of brass can be made from 25 kilogram of zinc? So we know brass 100% it's containing 72% of 72% of copper plus remainder is percent of zinc. So the percentage of zinc, it should be 100% minus 72 is 22% of 20 to 8% of zinc. So we know in 100% of brass, brass is containing of 28% of zinc, and then for 25, this one is percentage, this one is percentage, 25 of kilo of zinc, how many brass? So you can obtain X is 100 times 25 divided 28. You can know the total mass of brass. 100 times 25 over 28. 89.3. 89.3 kilo of brass. Okay, so uh, I hope you can understand. In this video, we discuss a lot on the molarity, normality, as well as the fraction. So I think that's all for this video. See you again next time. Assalamualaikum warahmatullahi wabarakatuh, and thank you very much.